You have to have a calculator for the test, or quiz, I'm sorry. It's very, very, very important that you do and that you know how to use it. So make sure if you guys have questions right now, you're asking. But chapter 6, section 6, Sebastian, come on. We're going to talk about solving exponential and logarithmic equations. One of the biggest things I want you guys to remember, write this down. Super duper important. 6.5 we did yesterday. So exponentials and logs are inverses of each other. E to the x and ln are inverses of each other. If you guys look at your calculator, there's a button that says I think your log button has 10 to the x on top of it. And then you have the ln button has e to the x on top of it. You are going to use those buttons to solve the equation. If you were going to solve an equation like 3x plus 2 equals 4, you have to undo, right? In order to get x by itself, you have to undo everything that's on that side. So what's the opposite of adding 2? You'd subtract 2. What's the opposite of multiplying by 3? Dividing by 3. So that's exactly what we're going to do. We're going to do that exact same process. We're going to isolate x, but the algebra 2 part of this is to understand that exponentials and logs are inverses of each other. So in order to undo an exponential, you have to take the log of both sides. In order to undo a log, you have to turn it into an exponential. So that's what we're going to talk about right now. Now there's one really basic property that says if the base on the left-hand side of the equation is the same as the base on the right, you can cross it out. Meaning, if I had like 7 to the x equals 49, I don't know, to the 4th, whatever. Are those two bases the same? Is 7 the same as 49? No. But could you rewrite 49 so it had a base of 7? Yes, I could rewrite 49 as 7 what? Squared, and then that 4 is still there. Now, what do you notice about the left-hand side of the equation and the right? The bases are what? The same. If you have an instance where you can rewrite to where the bases are the same on the left-hand side and the right-hand side, then these just cross out. And then your answer here would be x equals what? 8. 2 times 4 is 8. Now, with every single one of these, guys, you should know before you turn your homework in, before you turn your quiz in, if you're right or not. Because if you get x equals, what can you do with that x value? Plug it in. And you have a calculator. So we're going to do all types of different problems today. This is probably going to be a video that you're going to have to watch a couple times to go back and refresh your memory on how to solve. But let's go through. I just want to do a bunch of examples. All right, every time you're supposed to solve, I want you guys to kind of survey the situation. All right, I have a left-hand side and right-hand side. Is there a way, always try to do this first, is there a way to rewrite so the bases are the same? Let's think about this for a second. I'm going to rewrite this as 100x equals, yeah, how can I bring this up here? What would it become? What becomes negative? The exponent. This is 10 to the first, right? So if I could rewrite this as 10 to the negative 1 times x minus 3. Everybody agree? Is 100 the same as 10? No, but could I write 100 as a base of 10? How could I rewrite 100? 10 what? Squared times the x equals 10 to the negative 1 times x minus 3. What do you guys now notice that the left-hand side and the right-hand side both have? The same base. Now what can we do? You can cross it off. So on the left you have 2x equals, what do I do with this negative 1? I distribute it. So it gives me negative x plus 3. And can we solve this? Sure. Move numbers to one side, letters to the other. So I'm going to add x to both sides. So 3x equals 3. You guys agree? All right. And then I divide both sides by 3, and I get x equals what? 1. So my answer is x equals 1. How can I tell if I'm right? I can take this one and plug it in right there. You guys could do that in your calculator. You could hit parenthesis 1 divided by 10, close your parenthesis, and then raise it to the 1 minus 2 power. Sorry, not 1 minus 2. It's 1 minus 3. It is 2. 1 divided by 10, and then raise it to the 1 minus 3 power. What do you guys get? I have a charger. I'll let you charge it. Anybody?
1,000.
All right, let's look at B. What are my bases here? 2 and 7? Can I rewrite 2 to make it a 7? No, that's not going to work, is it? All right, so now we got to think. We want to isolate our x. We want to get x all by itself. Where is x right now? It's an exponent. Is this an exponential equation or is this a logarithmic equation? This is an exponential. So what is the opposite of exponential? Log. All right, so let's think. Let's think for a second. I'm going to have to take the log of both sides. So I'm going to write the word log here, and I'm going to have to figure out what kind of log I'm going to take. How could I get a big 2 to cross out if I'm using logs? What would the little number need to be? Perfect. I'm going to say log base 2 of 2 to the x. Whatever the big base is, in order for it to get crossed out, you use the big base as the little number. Good, Jeremiah. So what you do to one side of an equation, guys, you do where? To the other. So if I take log little 2 on the left, then I'm going to do what? Log little 2 on the right. There's one algebra 2 step in all of these problems, and the rest is just solving. What do I do with log little 2 and a big 2? What happens? It cancels out. So I have x equals. How would I put that in my calculator, guys? We know how to do this. Log what? 7 divided by log 2. That change of base formula. You got to use the change of base. So do that in your calculator. What is log 7? Here. What's log 7 divided by log 2? 3 point... Huh? 2... Okay, guys, say it, like, articulate. What is it? 2.807? 2.807. Thank you. Now, what can I do with that? I'm not going to check every single one, but I want you guys to see. If I take this and I plug it in right here, put 2 and then raise it to the 2.807 power. What do you guys get? Throw it in there. Hit 2 and then the caret button and then put 2.807. 6.998. Is that real close to 7? Yeah. Are you going to get the exact number? No, because we're approximating. But you're going to get something really close. So you guys can check and be like, oh, okay, cool. I got it. All right, let's look at the next one. Oh, there's not another one. Okay. All right, that's the same kind of problem. Tell yourself, what am I starting off with? Exponential, okay? Can I rewrite 2 and 5 say the same base? No. So if I'm starting off with exponential, what's the opposite? What's the inverse of exponential? Log. So what am I going to write on the left-hand side? Log little what? Log little 2 of 2x equals what? Log little 2 of? Perfect. What happens with log little 2 big 2? They cancel. Perfect. How do I write this? How do I do it with my calculator? It's log what? Log 5 divided by log 2. Give me 3 decimal places. A few of you do it. I don't have my calculator, so a few of you do it.
I got 2.312.
2.312? Okay, so 2.312. Perfect.
2.322. Oh, 2.1.
Okay. So 2.322?
Yes.
All right, perfect. Good job, guys. Good job. All right, is this problem any different? No. So the exponent has a 9 in it. Big deal. This is an exponential equation, so I have to undo the exponential. So what is this left side going to become? Log little 7 of 7 to the 9x. What you do to one side of the equation, you do where? To the other, log 7 of 15. So that cancels. Now, guys, this just becomes an algebra problem that you guys have done a million times in your life. What is log? Do this in your calculator. It's going to be log 15 divided by log 7. Again, we're going to be rounding, so we're going to approximate. Give me 3 decimal places. What do you guys got? 1.391. Okay. Now, what's the next step? What do I have to do to get x all by itself? Divide by. Perfect. So when I divide that by 9, you're going to get a teeny little number. What is it? 0.155?
Yes.
0.155. Now what can you do with that? Take that number and hit 7 and then raise it to the 9 times 0.155. You should get something real close to 15. You're never going to get the exact answer because we're rounding. But you should get something close, all right? So now let's go. Okay, this problem gets a little more complicated. You're like, man, we start to do good, easy stuff, and then it's like, oh. Look at what you're starting off with. Are we starting off with a log, an exponential like we were before, or does this have an e in it? It has an e. So look at this. Watch, I'm going to highlight the e because I want to get this e all by itself. Guys, look at your calculator. What's on the same button as e? ln. That means at some point, you're going to have to take the ln, the natural log of both sides. But I cannot do that until that e is all by itself. So what are the 2 steps I need to take? I'm going to add 7, just like you would solve any other problem. So I have 4e to the negative 0.3x equals 13 plus 7 is 20. All right, I still need to get this e all by itself. So what do? Divide by 4, perfect. So e to the negative 0.3x equals 5. Everybody agree? All right, so we're at this point. We haven't done anything more than Algebra 1. We just moved some stuff over. I recognize I have an e. I've got to get that e to go away. I have to get it to cancel out so my exponent will come down. What is the opposite of e? ln. So I'm going to take the natural log of this side. And what you do to one side of the equation, you do where? So we're going to take the natural log here. So on the left, ln and e do what? Cancel. So you have negative 0.3x equals, what is the natural log of 5? Hit ln 5. 1.609. You guys agree? Okay, so 1.609. And now we go back to basic math. How do I get x all by itself? Divide by negative 0.3. So x equals negative 5.365. Negative 5.365. Now, what can I do with that lovely x? I can put it right back in there. You guys could, in your calculator, you could hit 4. E, raise it to the negative 0.3 times negative 5.365. Minus 7. You should get something real close to 13. If I were you, I'd practice that this weekend. Just plug it in calculators. All right, now, let's talk about that. We were just talking about exponentials. Now we're talking about logs. We're going to do the same thing, guys. Look at what this says right here. Look at this. It says if log 2 of x and log 2 of 7. What do you notice in this example about the left-hand side and the right-hand side? Look at your equal sign. On the left-hand side and the right-hand side. Yeah, they're here. What do you guys notice about the left-hand side of the equal sign and the right-hand side that I highlighted? They're the same. What do you think happens if you have the same log on the left-hand side and the right-hand side? What do you think you can do? You can cross them off. Because think about it. The reason why, let me show you why. Sure, honey. Thank you. Have a good weekend. So log 2 of x equals log 2, 7, right? What is the opposite of log? Exponential, right? The opposite of exponential is log, so the opposite of log is exponential. So this is just backwards of what we were just doing. We had a big exponent, so we took the log of each side. Now we have logs, so we're going to make each what? An exponent. If I use 2 as your big base, what happens with 2 log 2 on the left? They cancel. What happens with 2 log 2 on the right? They cancel, so you're left with x equals 7. So if you have the same bases on either side, or you have the same log on either side, they can cancel. So let's talk about this. All right, I have natural log of 4x minus 7 equals the natural log of x plus 5. Okay? Anybody notice anything? The ln's are the same, right? I have 1 on one side, 1 on the other. What can you do? You can cancel them out. If you guys didn't realize that, you would say, okay, I'm not sure where to go from this. So I look at my calculator and I say, well, what's the opposite of ln? E. So if I take the e of this side and the e of this side, what happens with e and ln? They cancel. But if you guys notice, hey, I have the same thing on left side and right hand side, you're good to go. Cancel it out. So I'm left with 4x minus 7 equals x plus 5. You guys know how to solve this? Sure. I'm going to subtract x from both sides, yeah? And add 7. So 3x equals 12. What's x equal? Now, a lot of these logarithmic equations are going to say solve, check for extraneous solutions. We've talked about extraneous solutions before. What does that mean? Solutions that don't what? They don't work. Now, I don't need you guys to do this in your calculator, the full thing. What I do need you to do is check to make sure that when you plug in your number, this doesn't become negative. What's 4 times 4? Minus 7? 9. That's not a negative number, you're good. What's 4 plus 5? 9. That's not a negative number, you're good. I'll show you why in a second. But you cannot take the log of a negative number. If you put it in your calculator, it'll tell you error. So you got to be careful with that. Let's look at this one. All right, here's my equation. Log 2, 5x minus 17 equals 3. They don't have the same log on each side, so I can't just cross it off. So I say this is a logarithmic. What's the opposite of logarithmic? Exponential, okay? So I'm going to change this into an exponential equation. What is my big base going to become? 2. Why is it going to be a 2? Because that's what the little number is. You want it to cancel out. So in a sense, what you guys are doing, guys, you're going to write a big 2. I always exaggerate it. And then in the exponent goes log 2 of 5x minus 17. What you do to one side of the equation, you do where? So I'm going to write a big old 2, and what goes in the exponent? The 3. That's the new step that you guys are learning. That's it. Everything else now, we're going to solve a basic equation. What happens when I have 2 raised to the log 2? It cancels. So you're left with 5x minus 17 equals 8. 2 cubed is 8. And now what do we do? We're going to solve. Add 17 to both sides. 5x equals 25. Divide by 5 and x equals 5. I have to check just to make sure that my parenthesis, since it's a log, doesn't become negative. If I take 5, what's 5 times 5? 25 minus 17 is 8. Good. So you're good. Think about that, guys. It would be log 2 of 8 equals 3. If you were going to change that from log to exponential, this becomes big and these switch spots, right? Is that a true statement? Yep. You're good to go. Lots of problem solving, lots of thinking. That's why your homework all weekend is just going to practice this. Wednesday, we're going to practice. Monday, we're going to practice. It's just all practice. Oh, geez, here we go. We get the hang of it, and then I do this, right? Okay, so let's look at it. Solve log 2, log equals, First of all, what kind of an equation is this? Log or exponential? It's log. How do you know it's log? Because it says log. Okay, good. Can I just cross these two out?
No.
You're correct, but why not? Because they're on the same side. If it was one on one side of the equal sign, one on the other, we're good. So we haven't done anything yet, guys, where we've had two logs, but they're both the same. It's log base 10, correct? And log base 10. Do I know a way that I could rewrite this as just one log? What did we do yesterday? No. What did we do yesterday, guys? Oh, no. Wasn't even 24 hours ago. What did we do yesterday? We condensed and what? Expanded, right? We expanded and condensed. Can I smush those two logs together? Yeah. When I see the same log base, I can smush two logs together if they have the same log base. What does my addition become? Multiplication. Good. So I can rewrite this as log 2x times x minus 5. Do you guys agree? Am I allowed to do that? Absolutely. We smushed them together. Why can you do that? Because they both have the same log base. If you guys want to go ahead and multiply them together, you can, but you don't have to right now. Okay, so now this is the exact same problem that we just did 3 minutes ago. It says log base what? 10, because I don't see it. Log base 10 times 2x, x minus 5 equals 2. What do? This is a logarithmic equation. I've got to get rid of that log. How do I do it? Turn it to exponential. Perfect. What's my big base going to be, Jeremiah? Good, Ashley. I'm going to write a big old 10. And then what happens to everything? It goes up in the exponent. So 10 log 10, 2x times x minus 5. And what you do to one side of the equation, you do where? I'm going to write a big old 10. And where does 2 go? As the exponent. Perfect. Do we know how to solve this now? What happens with 10 log 10? It cancels. So I'm left with 2x times x minus 5 equals 100. Hello, algebra. What do I do? What's 2x times x? 2x squared. What's 2x times negative 5? Negative 10x. And then can I move this 100 over? So minus 100 equals what? 0. And we have a wonderful factoring problem, don't we? What do we look for first when we're factoring? GCF. What number can I take out of all three? 2. All right, take out that 2. So I'm left with x squared minus 5x minus what? 50, okay? Are there two numbers that would multiply to give me a negative 50, but add to give me a negative 5? Plus 10 and minus 5? Or minus 10 and plus 5? Minus 10 and plus 5, good. Just making sure y'all are with me. So now I set everything equal to 0. So 2 equals 0, x minus 10 equals 0, x plus 5 equals 0. How many answers should I have? How many answers should I have? 2. Does 2 ever equal 0? No, so you don't count that one. So I get here x equals 10 and x equals negative 5. Am I 100% sure that both of those work? No. What do I need to check for? I've got to make sure my log doesn't become negative, because if you guys hit log of a negative number in your calculator, it's going to say error, domain problem, can't do it. So let's plug in 10 up here. What's 2 times 10? 20, okay. What's 10 minus 5? So we're good. This one works fine. Okay, cool. What about negative 5? What happens when I say 2 times negative 5? Negative 10. Guys, hit log negative 10 in your calculator. What does it say? Error. Don't look at your friend and be like, oh, so I did something wrong. No, you didn't. You just broke the law. You're not allowed to take the log of negative number. So that is an extraneous solution. You don't have to write the word extraneous. Just cross it out. Let me know, hey, Miss Meadows, that one doesn't work. If it works in one but not the other, doesn't matter. As soon as it makes one of the logs untrue, cross it off. All right, we okay? Working? All right, I want to do these 4 together. We're going to do all of these, and then we're done. You guys are doing an awesome job, and I know this is a lot on a Friday. But, you know, math is fun. I know all of you say that. You go home, you're like, God, my math class is the best ever. Right? Right, everyone? Yep. All right, survey the situation. What's going on with number 5? Left-hand side, right-hand side is the... Number 5, left-hand side, right-hand side. ln. One ln on the left, one ln on the right. What can I do? Cancel them out. Cross them off. Now we're back to algebra. Can I solve this? 7x minus 4 equals 2x plus 11. Okay, perfect. Move x's to the left, numbers to the right. I'm going to subtract 2x from both sides, and I'm going to add 4. You guys okay with that? What's 7 minus 2? 5x equals 15. Perfect. X is equal to 3. Look at you guys. Am I right? 7 times 3 is good. 2 times 3. Yep, we're good to go. Good job. Good job, good job, good job. Let's do number 6. Log little 2 of x minus 6 equals 5. Okay. I got a log on the left. I don't on the right. So I got to get rid of that log. How do I undo logs? Exponentials. So I got to turn this into an exponential. But what is my big base going to be? How do you know? Good. Good, good, good. So I'm going to write a big 2. I always do this, guys. Write a bit, exaggerate it so you can see. So this is log 2, x minus 6, my exponent. If I have a big 2 on the left, I'm going to make big 2 on the right. What goes to the exponent? The 5. So what happens, guys, with 2 log 2? Cancels. So I have x minus 6 equals, what's 2 to the 5th power? 32. Now what do I do to both sides? I add 6. Perfect. So x equals 38. Check that. 38 minus 6. Is that going to give me a negative number? No. So you're good. If you want to go through the whole process, you absolutely can. 38 minus 6 is 32. So you'd have log 2 of 32 equals 5. You could do that in your calculator, log 32 divided by log 2, or you could change it to exponential and see that 2 to the 5th power is 32. All right, let's look at 8. Make sure I write this correctly. Log 5x plus log of x minus 1 equals 2. Okay, I'm starting off with a logarithmic, correct? Starting out with logs, all right. But I don't have one on one side of the equation, one on the other. They're both on the same side. So what do I need to do with them? I got to smush them together. The math word for that is condensing. But if you guys want to say smush it together, that's fine if you know how to mathematically do it. I can rewrite log one time. I'm going to put a little base of 10 there just so I don't forget. And when I smush together, when I condense, what does my addition become? Multiplication. When I see this, I go, ooh, that's multiplication. So I'm going to write this as 5x times x minus 1 equals 2. So now I have one log on one side, but I don't on the other. So I've got to undo this logarithmic equation. How do I undo this logarithmic? I turn it into, God bless you. What do I turn it into? Exponential. What is my big base going to be? A 10. I'm going to put a big 10 and then everything goes in the exponent. And what I do to one side of the equation, I do to the other. Good. So guys, what happens with 10 log 10? Cancels. So can I go ahead and multiply this? Are you guys okay with 5x squared minus 5 equals 100? Sorry, 5x equals 100. Okay. Now I have an x squared and an x, so I know, oh, okay, good, we're going to factor. So I'm going to bring everything to one side. 5x squared minus 5x minus 100 equals 0. And before I try and figure out what times what will give me this and that, I'm going to go ahead and take out the GCF. What can I take out of all three of these? A 5. Make your life easy, guys. So x squared, hang on one sec, Gigi. Minus x minus what? 20 equals 0. Question? Oh, okay. So I have my 5 out here. What times what, guys, will give me a negative 20 when I multiply, but a negative 1 when I add? What kind of 5, what kind of 4? Awesome. Minus 5 plus 4. So I'm going to say 5 equals 0, x minus 5 equals 0, and x plus 4 equals 0. Does 5 ever equal 0? No. So this is x equals 5, and this is x equals negative 4. Do I just pat myself in the back and say, oh, perfect? No. What do I have to check? I got to go way back to the top and make sure that neither log becomes negative when I plug it in. So try 5. 5 times 5, 25. 5 minus 1, 4. We're good. Okay, so 5 works. What about negative 4? Negative 4 times 5. Negative 20, no bueno. Does not work. It's extraneous. You can get a solution that when you go back and check, you're like, wait a second, that does not make my equation true. You guys doing great. One more. Log 4 of x plus 12 plus log 4 of x equals 3. Okay, this is a logarithmic, right? I can smush it. I love it. What about if there was a minus sign between here? Could I still smush it? Yeah, but what would my problem look like? Instead of multiplication, it would become what? Division. Okay, good. So I'm going to smush this. I'm going to rewrite it as log 4. This is going to become multiplication. If it was subtraction, it would become division. So I have x plus 12 times x equals 3. Perfect. So I have a logarithmic equation. What is the opposite of logarithmic? Exponential. What is my big base going to be if I have log base 4? It's going to be a big 4. So I'm going to write a ginormous 4. And then everything goes in the exponent. X plus 12 times x. And then over here I'm going to write a ginormous 4. And what goes in the exponent? 3. So 4 log 4 does what? Cancels. Are you guys okay with me multiplying here? So I have x squared plus 12x equals, calculators, 4 to the 3rd power. 64, okay. So move the 64 over. X squared plus 12x minus 64 equals 0. All right, so now we have to do what? Factor? Are there factors of 64 that'll multiply to give me 64 but add to give me 12? 1 and 64, 2 and 32, 3, 4 and... What's 16 times 4? What's 16 minus 4? Woohoo! We found it. Okay, so it's plus 16 or minus 16? What is it? I need a positive 12 in the middle. So plus 16 minus 4? Okay. So I get x equals negative 16 and x equals positive 4. What should I do? Let's check. Let's just check. Let's go back over here. Negative 16 plus 12. Yes or no? No. Cross it off. 4 plus 12. Yes. What would happen if you checked both of them and neither of them worked? No solution. Do you think there's ever a chance where you plug both of them in and they both work? Sure. You've got to make sure. There could be instances where they both work, There could be instances where neither of them work, or there could be instances where one or the other works. All right, you guys did fantastic today. I know that's a lot. So what I'd like you to do over the weekend at some point, rewatch this. Try to pull up some homework problems, practice them, go through, because it is a lot of information. But we're going to practice this for a few days next week and then take a quiz on Thursday.